Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 57 of Physics 5054. We were discussing the heat capacity. That was a general term, and today we are specializing it to specific substances, and the name of that topic is specific heat of objects. Ladies and gentlemen, in the last lecture we saw that heat capacity depends upon the mass as well as the material of the object. So it is more convenient to define heat capacity in terms of per unit mass or the specific heat capacity of objects. Ladies and gentlemen, it means that different objects are having different capacities. Yesterday we defined a general term which cannot be applied to every object in the same manner. Different materials or different substances having different capabilities of absorbing the heat. So we are specializing this general term to a specific term, and that is specific heat capacity. Ladies and gentlemen, there are two different phenomena about heat capacity and specific heat capacity. We will discuss those two differences, but let us first define the specific heat capacity. It is totally the same with one minute difference. What is that? Let us first define it. The amount of heat required to raise the temperature of 1 kilogram. This is different. This is different from the previous definition. 1 kilogram object. We are taking 1 kilogram of the object, whatever we want to examine for heat capacity, and then we will see that how much heat it is absorbing to raise the temperature through 1 Kelvin or 1 degree Celsius. So the total definition is the amount of heat required to raise the temperature of 1 kilogram of a substance through 1 Kelvin or 1 degree Celsius. Ladies and gentlemen, there was one difference, and that is 1 kilogram from the previous definition. Today we are going to discuss the second difference as well. And the second difference is that specific heat capacity is denoted by small c. In case of general heat capacity, it was defined by capital C, but to differentiate between specific heat capacity and only heat capacity, uppercase letter C and lowercase letter C are used respectively. Small c is equal to Q divided by M, where Q is the heat absorbed and M is the mass of the object. Yesterday we discussed that Q is equal to, this is not Q, this is capital C. So C divided by M. And yesterday we defined capital C as well, and that was equal to delta Q divided by delta theta. Q divided by delta theta. So if we are taking this 1 over M as common and writing C, so these two statements are equal. Now we are putting the values of this C, which is this one, Q divided by delta theta. So this is also the definition of specific heat. In one context, it can be written as like this. But in the second context, we can also write this is equal to, from this we can take that C is equal to C divided by M, which can be written as C is equal to Cm. This is another mathematical form of the specific heat capacity. Different questions are using different techniques in the question. So there is another form. Q is equal to MC delta theta. This type of mathematical expression can be used when we are starting the numerical problems on these topics. So, ladies and gentlemen, we are again defining the unit of specific heat capacity, joule per Kelvin per kilogram per Kelvin, or joule per kilogram per degree Celsius. The same unit as it was in yesterday's lecture. So ladies and gentlemen, think on it, that if the question is coming that what are the differences between heat capacity and specific heat capacity, one is this thing. This is not available in the heat capacity. It is only available in the specific heat capacity. One. The second thing is that specific heat capacity is denoted by small c, while only heat capacity is denoted by capital C. Second one. The third one is the mathematical form of the heat capacity is C is equal to Q divided by delta theta, while in case of specific heat capacity, the mathematical equation can be written in this particular form. If we are specifying the heat capacity to per unit mass, specific heat capacity is equal to heat capacity per unit mass. So generally we can write it like this. The second form is this one. So if the question is coming that write the three mathematical forms of specific heat capacity, then you have to write first this, and the third one is general heat capacity, which can also be written in this form. So these are the different form of heat capacities and general heat capacities. You can see these from the example. Here delta theta is the change in temperature, Q is the amount of heat absorbed by the object, and the quantity of mass used, which is 1 kilogram in the case of specific heat capacity. So you have to write all these things when you are explaining this specific heat capacity. Now we want to, and that is for a purpose, we want to see the heat capacities of different materials. That is why we are specializing this heat capacity, because every material is having different amount of heat to be absorbed inside that object. For example, lead is having 130 joule per kilogram per Kelvin. Similarly, mercury is 140. So what do you think that who will give you the rise in temperature quickly, lead or mercury? If this question is coming in your CIE exam, lead heat capacity is 130 joule per kilogram per Kelvin, and the specific heat capacity of mercury is 140, and the question is saying that which object will give you quick rise in the temperature. So it will be lead, because the specific heat capacity is 130. It means that 130 joule of heat is required to fill this lead completely with energy. No more storage will be there in the lead. But mercury is having 140. So it means that 140 joule of energy is required to completely fill the molecules of mercury with the energy. When the completion of energy in the molecules is occurring, then after that it will start rising the temperature of the material. So many students are confusing themselves that 130 is a smaller temperature and 140 is a larger temperature. So it means that mercury will increase very quickly. One wrong concept they are taking, that this is not the temperature, this is the amount of heat that is given to these particular object to raise their temperature by 1 Kelvin or 1 degree Celsius. So generally you can say per unit. So whatever unit are you taking. So it means that these values are given in the gravitational order, that is in increasing order. This is small, this is larger, this is larger, this is larger, this is larger, and this. So these things are given that if we are taking copper, so it means that 400 joule of energy is required for 1 kilogram of copper to be completely filled with the energy. Heat is a form of energy. So 400 joule is required to raise the temperature of copper by 1 unit. Might be it is Kelvin or degree Celsius. So I am saying generally the unit. So here the very important one is written at the last. We will use this 4200 joule per kilogram per Kelvin in many of the numerical questions. Always they are giving you this value, but if by certain means they are not giving you this value, then you have to memorize that the specific heat capacity of water is 4200 joule per kilogram per Kelvin. What does it mean? It means that 4200 joule of energy is required for 1 kilogram of mass of water to fill all their molecules and make them energetic to move from one part to another part. So remember, specific heat capacity, this is the nutshell. Specific heat capacity of the object are different for different materials, as you can see those from this table. So this is the question. If we want to see that what is the change in temperature for copper, 1 kilogram of copper. So there will be Q divided by MC. This is also a formula, ladies and gentlemen. This is also, and you move this delta theta on this side and you brought this C on the place of delta theta. Now you can see that there is 4200, mass is 1 kilogram, and the specific heat capacity for copper is 400. So it means that these two zeros will be cancelled with this one, and if we are calculating this, so it will be 10.5 degrees Celsius. Ladies and gentlemen, what does it mean? It means that 10.5 degrees Celsius rise in temperature will fill all these molecules of copper with the energy. That much change in temperature is required. So now we are turning our focus to the work example, and we will utilize our knowledge of the specific heat capacity. If we understood this work example, then it means that we will be able to utilize our knowledge. I tried my best to teach it in a very simple way. There is no simple way than this explanation. Let us see that whether you can help me in solving this question. But before that, let me tell you one thing more. From the comparison of these material, the lower specific heat capacity will heat up to a higher temperature. That is what I told you. Lower specific heat, it will go to higher temperature very quickly. And higher specific heat capacity will go slowly to rise the temperature of 1 kilogram of a substance. This is very important. This question can also help you that from this table, what you are thinking, that the low heat capacity object will go higher change in temperature, or the higher specific heat capacity will go. So you have to think that lower heat capacity will fill the molecules with energy very quickly, and the rise of temperature will go very quickly. While in case of the higher specific heat capacity, first they have to utilize this much energy to make the molecules fed up with the energy. After that, they will not absorb more heat, so it will rise the temperature of that object. So that was one thing more I wanted to tell you, and that is very important. Let me erase the whiteboard and then we'll come back. Wait for 1 second only. Okay, let us start work example 10.2, and it is on page number 146. It is saying that an electric heater coil supplies 50 watt of power. So P is equal to 50 watt. This is the given data. To a metal block of mass M is equal to 0.60 kilogram, and rises the temperature of the block from 20 to 45. So delta theta is equal to 45 degrees Celsius minus 20 degrees Celsius. 20 degree Celsius, which is equal to 25 degrees Celsius in 90 seconds. So T means 90 seconds. Write the data as you are facing it. Calculate the specific heat capacity of the metal. I am writing small c. Specific heat capacity of the metal. Okay, one final question. What assumption did you make to arrive at your answer? First of all, the assumption we will make is that the heat doesn't go to the surrounding. The heat which is given to the metal is totally absorbed. inside that material, this assumption should be there. If it is spreading to the environment, then you will not get a very good answer, quality answer. So let us see that what is heat supplied by the heater. Q is equal to P cross T. P is given and T is given. So it means that 50 multiplied by 90, and that is equal to 4500 joule. 4500 joule. That is one part. And we are saying heat absorbed. This is heat supplied. Heat supplied and heat absorbed. That is what we made the assumption, and that is equal to MC delta theta. MC delta theta, and M is given as 0.60. C we have to find, and delta theta is 25 degree Celsius. So whatever assumption heat we made, heat supplied is equal to heat absorbed. It means that we are making the assumption that no heat will get out from the system and will go to the environment. No, so we are putting the values, that is P cross T is equal to M C delta theta. Remember that this C is the specific heat capacity. So we found this to be 4500 joule, and we are putting 0.60 into C into 25 degree Celsius. So C is equal to 4500 divided by 0.06 multiplied by 25 joule per kilogram per Kelvin. That is the unit of specific heat. And when we calculate it, we will get 300. C is equal to 300 joule per kilogram per Kelvin. And that is the ultimate answer of this question. Since the specific heat capacity, hence the specific heat capacity of the metal is 300 joule per kilogram per degree Celsius. Ladies and gentlemen, with this we reach to the end of the theoretical portion. I told you in the previous lecture that in the upcoming few chapters we will discuss the simple kinetic theory of molecular theory of matter. So in that context, that was the second chapter in which we studied heat capacity and specific heat capacity. This completes the theoretical portion of topic number 10. There are 25 topics inside this course. Not only IGCSE but also GCSE can take advantage of these courses. So share it with your friend, and if you are applauding me, then subscribe my channel and share it with your friends and family members like brothers and sisters. They can take advantage of these topics as well. Tomorrow we will utilize our knowledge gained theoretically in practical situation. I will check your IQ level, will give you the time, think on the answer, then I will tell you the answer, whether your answer is correct or not. Thank you very much for watching. Allah Hafiz.